For question 9, I'm hoping you're getting the hang of this, so let's simplify this a little bit. We'll have 2 sine x is equal to -1, so sine x is equal to -1/2. And on a unit circle, there are 2 places where this is going to be the case. They're both in the bottom half of the graph, so the 3rd quadrant and the 4th quadrant. And we know that the rectangular coordinates have got to be √3/2, 1/2. So I know this is some multiple of pi over 6. So 6 pi over 6 would put me here. So one solution is going to be at 7 pi over 6, and the other one has got to be at 11 pi over 6. So our solutions are going to be x is 7 pi over 6 plus 2 pi n, or x is 11 pi over 6 plus 2 pi n. For question 10, this gets kind of nicer. Here we have a quadratic equation, and the only way to solve a quadratic is to use the zero product property. We can. So let's factor out sine x. We're going to be left with sine x minus 1 is equal to 0. And then by the zero product property, sine of x is equal to 0, or sine of x is equal to 1. Well, sine of x is equal to 0, we know, on a unit circle at here, or here, or here, or here. So at any multiple of pi. So I'm going to just call this pi times n. You also, alternatively, could refer to the graph of sine x. And we can see that sine of x is equal to 0 here, and here, and here, and here. So again, this is at pi radians and 2 pi. Sine of x is equal to 1. Well, you can either look at the unit circle. So that would be at x is pi over 2 plus 2 pi n. There's only one place where that's the case. Or look at the graph of sine. Over here, this is where sine of x is equal to 1 at pi over 2. But we're going to also find a spot if we add 2 pi radians.